Hello, third graders. We are in Unit 5, Light and Sound, and today's lesson is called What is Color? Some words you'll hear throughout the read aloud. These are all nouns, so they're all things. Optometrist is a doctor who examines people's eyes to check if their vision needs to be corrected in any way by wearing glasses or contact lenses or by medical treatment. Prism, a transparent, often triangular object used to refract and divide white light into its different colors. Rainbow, a curved band of colors in the sky that sometimes occurs when sunlight passes through raindrops and the light is refracted into different colors. Spectrum, a series or range of objects, things, or ideas arranged in a particular order. Wavelength, the distance between waves of energy. White light, light that includes all of the colors of the spectrum, can be broken up into a spectrum of colors by a prism. And then X-ray, a powerful invisible ray of energy that can pass through an object and make it possible to see inside of it, a picture that shows what makes up the inside of something, such as the many bones of the skeleton. So let's talk about our story elements because we're reading a narrative story to find out about light and sound. So we have some main characters, right? Our main characters in our story are Samuel and Jack, but now we've been introduced to two new secondary characters. Who were the two new secondary characters we learned about yesterday? That's right, Samuel's grandchildren, Ethan and Amy. What adjectives would you use to describe Ethan and Amy? Well, you could say they're young. You could say that they're nice and kind. They're loving. They love their grandpa. They're curious. They want to know about things. You could also use the word inquisitive, which is kind of like curious. It's when you want to know about a lot of things. They're smart. They seem to get along pretty well, which is good for siblings. How do Ethan's and Amy's interests and actions contribute to the events and discussions that occur in this domain? Well, they ask their Uncle Samuel questions, right? And they seem interested in light and mirrors and different reflections and things like that. They're interested in looking in the House of Mirrors when they go to the fair. They're interested in the rides and different things. And that's mainly why they go to the fairs, because Amy and Ethan are interested in going there. It was a sunny Saturday morning, and Samuel had invited Amy, Ethan, and Jack to breakfast. It had been 3 days since Samuel had seen Jack and his grandchildren, because he had traveled to the city to a special hospital to have his eyes checked by an optometrist. Samuel set up 2 extra easels in the garden next to his easel. He was trying to encourage his grandchildren to paint with him. He had long since given up trying to get Jack to take up painting as a hobby. When he was at the hospital, the optometrist had advised Samuel to rest his eyes, but he found it difficult to give up his daily trip to the garden to paint. Amy and Ethan arrived first. They really enjoyed having breakfast with their grandfather. Samuel always served homemade pancakes, eggs, sausages, bacon, and hash browns. The breakfasts were always amazing. "Hey, Granddad," yelled Ethan, "I'm starving. Is breakfast ready?" "I doubt you are actually starving," replied Samuel, "but it's almost ready. Just scrambling the eggs." Moments later, Jack arrived just in time to help Samuel serve the breakfast feast. Once the food had been served, Alfie arrived in the kitchen in the hope of getting a tasty morsel. Samuel pretended to be strict about feeding Alfie from the table, but in truth he liked to spoil him. "You've outdone yourself," said Jack appreciatively. He too enjoyed Samuel's famous breakfast. "What's the plan for today?" asked Jack, hoping that there wouldn't actually be one. "Well, I'm going to make these two monkeys work a little," said Samuel, grinning. "They're going to have a painting lesson, and all 3 of you are going to have a lesson on the science of color." "That just means he's going to talk a lot," announced Jack. The children laughed. Excuse me. Samuel, Jack, and the children spent the next hour eating, talking, enjoying each other's company. Ethan secretly reached down under the table and fed Alfie small pieces of sausage, though Samuel was perfectly aware what was going on. Then, after loading the dishwasher and tidying up the kitchen, they made their way out into the garden. Samuel had set the easels up under the shade of the large apple tree. Once everyone was settled, including Alfie, he advised the children to pick a subject to paint, something that they could clearly see and would enjoy painting. "I'd like to paint the bird feeder," pronounced Ethan. "I think I'll paint that potted geranium," said Amy, pointing to a plant with vivid red petals, sitting snugly in a terracotta pot. "I've chosen to sit here and close my eyes," said Jack, and then promptly did just that. "The first thing I want you to understand, and I've already explained this to Jack, is that waves of light energy race through space from the sun to Earth," Samuel began. "Every type of light energy has its own unique wavelength. We cannot see all of the sun's light energy, but the energy we can see is called visible light. White light is made up of a spectrum of all the colors we see in visible light. Some light is invisible, such as X-rays," continued Samuel. "That's complicated," chimed in Ethan. "Not really," said Samuel. "I agree with him," said Jack, opening one eye and pointing at Ethan. "Oh, let me finish explaining, and it might make some sense," continued Samuel. "We need light to be able to see. Light from the sun travels to Earth. Most of it is invisible to us unless we have equipment like X-ray machines. The visible light shines on objects in the world around us. Some of the light reflects off objects and into our eyes. Then parts of our eyes receive that information and communicate with our brain. The brain figures out what colors we are seeing. However, and this is what is really interesting," said Samuel eagerly, "the color of an object is determined by whether that object transmits, reflects, or absorbs light. Sometimes it is a combination." So, a wavelength is the distance between the crest or tops of two waves. Some waves are longer than others. So if you look at this diagram right here, you can see that the wavelength for like a radio and a microwave and infrared is longer. So you start at the crest and go to the other crest, and that's the wavelength, is the distance between the two. Can you tell me which type of visible light has the longer wavelengths, right? The microwave or the X-ray? Well, microwave is over here on the left, and there's more space between the peaks, the crests of the waves. Then over on the right, you see X-ray, and they're closer together. Okay, and you can see the different lights that are made with the different rays. The visible light you can see is towards the middle and has like a medium wavelength. And you see the colors that we can see. So this graph shows all the wavelengths of light energy coming from the sun. This range of wavelengths, red, orange, green, yellow, green, blue, indigo, and violet, is visible to humans without using any special equipment. Do these colors remind you of something familiar? They're the colors of the rainbow. A rainbow is light that we see. An X-ray is a powerful invisible ray of energy that can pass through an object, and special X-ray machines make it possible to see what is inside. We talked about X-rays when we talked about the skeletal system in our human body unit. "Oh, it's so much easier to understand now," joked Jack. "Think of it this way," continued Samuel. "Look at the grass. It looks green because it reflects green light waves, but it absorbs the other wavelengths of visible light, meaning it absorbs all the other colors." What does absorb mean? Asked Ethan with a puzzled look on his face. He had by now finished sketching the bird feeder and was dipping his paintbrush into some carefully mixed brown paint. So if we look at this kid and see his red shirt, what wavelength of light is reflected from the shirt? Red, because that's what we're seeing. So that shirt is absorbing every color but red. So the red bounces off and is reflected and we see it. It goes into our eyes and we see it. Absorbed light is the light that is soaked up by an object and is therefore no longer visible. The color you see when you look at an object is actually the reflected light. An object has no color if there is no reflected light, explained Samuel. Oh, I get it, said Amy, who by now was painting the terracotta pot. That's why my art teacher said that black materials absorb all colors of light and do not reflect any. So in a way, black is not a true color. It is more a lack of light. That's exactly right, Amy, said Samuel. White is the opposite of that. An object that appears white to our eyes reflects all the colors of the spectrum and absorbs none of them. Is that why people say you should wear white clothes in the summertime? Asked Ethan, who was concentrating hard on painting the roof of the birdhouse. Exactly, exclaimed Samuel. White material reflects most of the light that hits it and absorbs very little. So if you wear white clothing, you tend to stay a little cooler. Who would like some ice cream? Asked Jack loudly, changing the subject. He had grown restless and wanted to do something fun. Yay, ice cream! Screeched Ethan. Yes, please, said Amy. Here's an interesting question, said Samuel. Which would melt first, chocolate or vanilla ice cream? The children frowned thoughtfully. Chocolate, called Ethan. And why is that? Asked Samuel. Because it's a darker color and would absorb more light, said Amy. Very good, said Samuel. Do you have mint chocolate chip? Asked Ethan. Oh, that's my favorite, yelled Jack. Mine too, agreed Ethan. Do you have strawberry ice cream? Asked Amy. I sure do, said Samuel. How about we go inside and cool off with some ice cream? Samuel didn't need a reply. Jack and the children were already walking towards the kitchen door. They hadn't realized it, but they had been out in the garden for quite some time, and in that time rain clouds had gathered in the distance. Moments later, Samuel, Jack, Amy, and Ethan were sitting at the kitchen enjoying double scoops of ice cream. Amy and Ethan had drizzled chocolate sauce on top of theirs. There was even a very small scoop of strawberry ice cream for Alfie, even though Samuel knew he really shouldn't have any. Hey, what do you call a ghost mother and father? Asked Ethan as he licked chocolate sauce from around his mouth. I don't know. What do you call a ghost mother and father? Replied Jack. Transparents, announced Ethan. Ha ha ha. Which one runs faster? Hot or cold? Ethan continued. Hot. Everyone can catch cold, answered Amy. Ah, you've heard it, said Ethan, sounding disappointed. Okay, how about this one, said Amy. Why is it so hot in a stadium after a football game? Samuel, Jack, and Ethan thought for a while, but could not come up with a good enough answer. Okay, smarty pants, tell us the answer, said Jack. Because all the fans have left, said Amy, clearly delighted with herself. Look at that, said Samuel, pointing through the kitchen window. It's a rainbow, exclaimed Amy. Oh no, he's going to tell us how they are formed, said Jack, pointing his spoon at Samuel. Well, as a matter of fact, replied Samuel, a rainbow is a perfect spectrum of colors. We see this spectrum when waves of white light encounter millions of falling raindrops, just like the glass of water in the straw Ethan. The light waves slow down and reflect when they come into contact with the transparent raindrops. Essentially, beams of white light break apart into the colors of the rainbow. Each transparent raindrop acts as a prism, perfectly splitting white light into all its colors," explained Samuel. "Oh, we used prisms in class," shouted Ethan. "It was so cool. It was like making your own rainbow." Lots of people use this acronym to remember the order of the colors of the rainbow. If you remember Roy G. Biv, maybe you've heard that before, maybe in art class. Roy G. Biv, the colors of the rainbow in order: red, orange, yellow, blue, indigo, and violet. Roy G. Biv. A prism is a transparent object such as water, glass, or plastic that refracts and divides white light into a spectrum of colors. Samuel, Jack, Amy, and Ethan continued to chat and joke and enjoy each other's company. After a while, they returned to the garden where Samuel continued the painting lesson. He advised the children to pay attention to the angles and qualities of light and shade that hung in the air like soft, clear, transparent wings. He talked to them about texture and tone. All the while, Jack sat in his garden chair and napped. Morning turned into afternoon, and afternoon to early evening, and no one wanted to leave the comfort and shade of the beautiful garden, not even Alfie. All right, that's a fun story. So what is visible light? Visible light is light that we can see. You have heard that white light is related to visible light. What is white light made of? Here's a hint. Remember Roy G. Biv. White light is all the colors we can see in visible light: red, orange, yellow, green, blue, indigo, and violet. How does light travel? Light travels in waves. How are light waves measured? Light waves are measured in wavelengths from the top of one wave to the top of the next. Why did the shirt in the picture appear red? The red shirt absorbs all of the colors of white light except the red light. The shirt reflects the red light and we see the shirt as red. What causes an object to look black? Black is the absence of reflected light that occurs when all of the colors of the spectrum are absorbed. So there's nothing being reflected back when you see the color black. What causes an object to look white? White is what we see when all of the colors in the spectrum are reflected. So that means no colors are absorbed, they're all reflected. Then we see white. Here's a question. In a completely dark room, is it possible to see colors? Why or why not? No, because there's no color without light. We can't see things. There's no color without light because there's nothing to be reflected or absorbed, and that's how we see things. All right, our word for today is spectrum. In the read aloud, you heard a rainbow is a perfect spectrum of colors. The rainbow shows, can you say the word spectrum? The rainbow shows the spectrum of colors that are produced when white light passes through the raindrops in the atmosphere. A spectrum is a series or range of objects, things, or ideas arranged in a particular order. Max could see the entire spectrum of colors after the light went through his prism, and he noticed that the colors were in the same arrangement as the rainbow he had seen in the sky after the thunderstorm. Have you ever seen a spectrum of colors before? What was causing the spectrum? Good job, guys. I hope you enjoyed learning a little more about color.